Okay, so what we have here is we're going to try to find the distance between a point and a plane. And when we say find the distance between, we really mean the minimum distance. How close does the point get to the plane? Or how close does the plane get to the point, whichever way you're looking at it. So we have the point -1, 2, 5, which is definitely not on the plane. X plus 4y minus 3z equals 12. So looking at our visual here, so this black line here is our plane. And the way we go about this is we select a point that's on the plane. I'm going to pick the point 0, 3, 0. It's always handy to use as many zeros as you can. So that's our point P that's on the plane. And what we do is we look at the vector PS, or the line segment PS. And what we do is we compare it to the normal vector. So the normal vector runs this way. And we know that that's a right angle because the normal vector is perpendicular to the plane. And what we notice is that the angle between the normal vector and vector PS moving in either direction is theta. And remember that the distance formula that we derived is the absolute value of the dot product, PS dot n, and that's divided by the magnitude of n. Okay, so, and that just comes directly from the cosine of theta formula with the dot product of two vectors. So let's find vector PS. So PS is the vector. Well, let's see. If we're going from P to S, P is the point 0, 3, 0. So we're going from 0 to -1, so that's -1. We're going from 3 to 2, so that's again a -1. And we're going from 0 to 5, so that's a 5. So vector PS is -1, -1, 5. The normal vector to our plane comes from the coefficients of x, y, and z in the plane. So that is 1, 4, -3. And then PS dot n is equal to -1 times 1 minus 1 times 4 plus 5 times -3, which looks like it's equal to -20. Okay? And the length of n, or the magnitude of n, is the square root of the squares of the components added together. So it looks like it's 1 plus 16 plus 9, which is square root 26. So the distance is equal to the absolute value of -20 over the square root of 26, which is 20 over square root 26. And then, of course, if you feel like it, you can rationalize the denominator. It doesn't really get you much further. That's about as clean of an answer as we can get. So there's our distance between a point and a plane.